Hey, and welcome! Today, we're basically becoming financial detectives. Our mission? To uncover a hidden signal, a secret opinion that the market has about a company's health. So let's get right into the investigation.
You know, we hear what the analysts are saying, we all read the news, but what if we could just listen directly to the market? What if we could take the actions of thousands and thousands of investors and boil it all down to one single, powerful number that tells us what they really think about a company's risk of going bust? Well, that's the mystery we're going to crack today.
And this secret we're hunting for, it actually has a name: the market-implied probability of default. Put simply, it's the chance a company won't be able to pay back its debts. The key here, though, is that this isn't some expert's guess. No, this is a probability that's baked right into the market price of its bonds. And that number, that's our target.
All right, so any good investigation starts with evidence. So our first step is all about gathering the raw clues we need from the real world. We've got to get our hands on the data.
And where are we getting these clues? We're going straight to the source, the Financial Industry Regulatory Authority, or FINRA. They have this amazing public database called TRACE, which is full of bond trading data. We're heading right there to get the prices we need for our analysis.
Now, to grab all this data, we're not going to sit there and click around all day. No way. We're going to use this really cool automation tool called Playwright. You can think of it like our digital detective's assistant. It can go to the website, fill out the forms, and scrape all the bond data for us automatically. Super efficient, super precise.
Okay, but here's the thing about any kind of data investigation. A little dose of reality. The clues you find? They are rarely clean. Real-world data is messy, it's jumbled, and it is definitely not ready for analysis right out of the box. And our bond data is no different.
So take a look at this. This shows us exactly what I mean. See how every single one of these columns is listed as an object? That's just a fancy way of saying our program thinks everything is just plain text. The price, the coupon rate, even the dates, it's all just text. You can't do any math with that. It's totally useless to us right now.
And voila! After a bit of digital scrubbing, look at the difference. Now our prices and rates are float 64, which means they're proper numbers. The maturity date is a date-time object. Suddenly, our clues are organized, they make sense, and they are ready for the next phase of our investigation.
So we've got our clues, but a clue without context is pretty meaningless, right? So in this step, we need to build a framework. The context we need to actually understand what our data is trying to tell us about risk.
Before we can say whether one particular bond is risky, we kind of need a ruler to measure it against. I mean, what does a normal level of risk even look like? To figure that out, we need a benchmark, a reference point from the wider market.
And that benchmark is called the risk-adjusted discount rate. It's a really fundamental idea in finance. It all starts with the interest rate you'd get on a totally risk-free investment, like a government bond. And then it adds a little extra on top, a premium, to make up for all the extra risks you take on by investing in a corporate bond instead. So what exactly is in that extra risk premium? Well, it's a mix of a few things. The biggest one, of course, is the default risk premium. But you also get compensated for stuff like liquidity risk, how easy is it to sell the bond, and maturity risk because, hey, a lot can happen over 30 years. All these little premiums add up to create the spread that makes corporate bonds pay more than super safe government bonds.
Building this benchmark rate is a really methodical process. As you can see, we start with a risk-free rate. The 10-year Treasury is a great stand-in for that. Then we add on a market risk premium to account for just the general riskiness of the corporate bond market. We put those pieces together and we get our risk-adjusted discount rate. That's the ruler we need for our investigation.
Okay, this is it. This is the moment we've been building up to. We've gathered all our clues, we've established the context. Now it's time to put it all together and finally solve this case. So let's just do a quick inventory of what we know. We've got the bond's current price from the market. We know the exact cash flows it's supposed to pay out in the future, all those coupon payments and the big final principal payment. And we just figured out the correct risk-adjusted rate to use. We have all the pieces of the puzzle. Well, except for one. And this slide just lays it out perfectly. The basic bond valuation equation says that a bond's price should equal the discounted value of all its future cash flows. Here's the cool part. We know the price, we know the payments, and we know the discount rate. The only thing left in that entire equation that we don't know is P, the probability of default itself. It's the only missing variable.
And this is basically the magic wand.
This one line of code is where we let the computer do the heavy lifting. We use what's called a solver function, and we basically just say, hey, computer, here's the equation, and here are all the numbers we know. Now go find the one value for p that makes both sides of the equation match up. It is the computational aha moment.
And there you have it. The solver does its thing, crunches the numbers, and spits out our answer. Based on everything, the market price, the coupons, the maturity, our risk benchmark, the market is implying a 1.34% probability that this company will default on this bond. The case is solved.
So we did it. We have our number. But a number is just a number until you really understand what it means. What did we actually just find here?
That 1.34%, it's not some analyst's opinion, and it's not from a fancy forecasting model. It is a direct signal from the market itself. It is the consensus view on risk, created by the real money decisions of thousands of investors every single day. We've literally taken the market's hidden opinion and dragged it out into the light.
And this is where it gets really powerful. I mean, what can you do with this? You can track this number over time and watch the market's perception of risk change in real time. You could compare it across different companies in the same industry to see who the market thinks is the safest bet. And maybe most importantly, you can compare it to the official credit ratings, which, let's be honest, are often slow to react. This gives you a forward-looking view that a lot of people might be missing. So, in the end, what we've really done here is translate the complex, sometimes chaotic language of the market into a single, clear number. It's a living, breathing insight into risk that changes every single day. We've shown you how to decode the market's secret opinion. So the real question is, what are you going to do with it?